Kurt Gödel proved that mathematics can never prove everything. It is the most famous limitation in the whole subject, and among his private papers, unpublished, shown to almost nobody in his lifetime, he left something else: a formal proof of the existence of God. The mathematicians who thought they had found God. What is documented, and what was invented? It belongs to a family of arguments that are nearly 1,000 years old, and they all have the same strange shape. They do not look at the world. They do not point at a sunset, or a cause, or a design. They start from a definition of what God would have to be, and they try to argue from the definition alone that such a thing must exist. Anselm made the first one in the 11th century. Descartes made another. Almost everyone who hears one for the first time feels that a trick has been played, and almost nobody can immediately say where. Gödel's version is not rhetoric. It is written in modal logic, the branch that deals with necessity and possibility. 5 axioms, 3 definitions, a chain of theorems laid out the way you would lay out anything you intended other people to check. And in 2013, 2 computer scientists did exactly that. They translated it into a language a machine could read and handed it to an automated theorem prover. The machine found something Gödel had missed. We will come back to what it found, because it is stranger than either side of this argument expects, and it takes the rest of the video to earn properly. First, a bigger question. Why do serious mathematicians keep doing this? Not cranks, some of the best who ever lived. Let me be clear about what this video is, so nobody waits for a reveal that never comes. It is not going to tell you whether God exists. It is going to separate what is documented from what was invented. There is far more of the second than you would expect. Start at the beginning, because the beginning explains a lot. The Pythagoreans were not a mathematics department. They were a religious order, and the thing they worshipped was number. The tetractys, 10 dots arranged in 4 rows, was an object of devotion. They swore oaths on it. Mathematics did not drift towards religion at some later date. In the West, it started there. 2,000 years later, Johannes Kepler thought he had found the blueprint. There are exactly 5 Platonic solids. 5. And in Kepler's day there were 6 known planets, which leaves exactly 5 gaps between their orbits. He nested the solids inside the orbits, 1 in each gap, and the fit looked close enough to be a message. Geometry is one and eternal. He wrote, a reflection out of the mind of God. He was wrong. The model does not fit. The orbits are not spheres, the spacing is not what the solids demand, and there are more planets than he knew about. But here is the part worth sitting with. Kepler was so convinced the fit had to be exact that he spent years chasing the discrepancies. And chasing those discrepancies is what produced the 3 laws of planetary motion that we still use. The theology was wrong. The obsession it created was productive. Isaac Newton wrote more on theology than he ever wrote on physics. Not slightly more. Millions of words, most of it never published, much of it on biblical chronology and prophecy. When his papers were finally auctioned in 1936, the economist John Maynard Keynes bought a large part of them, read them, and said that Newton was not the first of the age of reason. He was the last of the magicians. That is not a footnote about the man. It is what he thought the work was. Georg Cantor proved that some infinities are larger than others. He also believed that the transfinite numbers had been shown to him, and he meant that literally. He wrote to Catholic theologians about it, including Cardinal Franzelin, because a real worry had occurred to him. If an actual completed infinity exists inside mathematics, does that trespass on the uniqueness of God? His answer was to put something above the whole hierarchy. The infinities Cantor built go up forever. Each one is bigger than the last, and there is no top. So he placed something beyond all of them, which he called the absolute infinite. Not a larger number, something that could not be reached by the process at all. And he identified it, in writing, with God. Srinivasa Ramanujan said it plainest of all. An equation for me has no meaning unless it expresses a thought of God. He said the formulas came to him from the goddess Namagiri in dreams. Whatever you make of the source, the formulas were right. Some of them were so far ahead of the mathematics of the time that it took a century to prove them. Now the numbers that people point at, this is where it gets messy. Most constants in physics depend on the units you chose. The speed of light is a different number in miles per hour than in meters per second, and that tells you about your ruler, not about the universe. But a few constants have no units at all. They are just numbers. Change every unit you like and they do not move. And there is one of those that governs how strongly light and matter interact. Richard Feynman called it one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. You might say, he wrote, that the hand of God wrote that number, and we do not know how he pushed his pencil. You will hear that number quoted as 1 over 137. Hold on to that, because it is not the value. The measured number is 137.036, and the digits carry on past that. It is not a whole number. It is not close to being a whole number. Remember this in about 2 minutes, because it is going to matter. Wolfgang Pauli spent a large part of his life trying to derive that number from first principles. He never managed it. He said that when he died, his first question to the devil would be, why the number has the value it does. In 1958, he was admitted to the Red Cross Hospital in Zurich with pancreatic cancer. His last assistant, Charles Enns, came to visit him. Pauli asked whether he had seen the room number. It was 137. He died in that room. And now the part that needs a warning label. Arthur Eddington was one of the most respected astrophysicists alive, and he tried to derive the constant from pure reason. He produced an argument that it was exactly 136. When better measurements came in, he revised the argument and got exactly 137. Both of those are whole numbers. The constant is not a whole number. An argument that can be adjusted to land on whatever the measurement says is not a derivation. It was mocked as numerology at the time, and colleagues took to calling him Sir Arthur adding 1. The same thing happened to a number in mathematics. In 1509, Luca Pacioli published an entire book about the golden ratio, and he called it On the Divine Proportion. Leonardo da Vinci drew the illustrations. That part is completely real. The title is not a modern exaggeration, and the ratio itself is a genuinely interesting number. Almost everything you have been told about it since is not real. The Parthenon was not designed around it. You can fit a golden rectangle to the front of the Parthenon, but only by choosing where to put the edges, and different people choose differently. The Mona Lisa was not composed with it. There is no evidence Leonardo used it in any painting. And the Nautilus shell, the one on every poster and every textbook cover, does not have it either. The Nautilus is a real logarithmic spiral. That much is true, but it is the wrong logarithmic spiral, and you can settle it with one number. A golden spiral gets wider by a factor of 2.62 on every turn. a nautilus shell gets wider by a factor of about 3. Those are not the same, they are not close, and anyone could have checked at any point in the last 100 years. These claims were repeated until they became furniture. The most repeated story in this entire subject did not happen either. You may have heard that Euler confronted the atheist Diderot at the Russian court, announced a meaningless equation, declared that therefore God exists, and left him speechless. It reaches us from one man. Thibault, writing in 1804, decades later, who does not claim to have been present. He says only that the story was believed. It was then embellished by later retellers until it became the version you know, and Diderot was perfectly competent at mathematics. He wrote on probability and on acoustics. He would not have been baffled by an equation. That is how a story becomes furniture. So strip all of it out. Every fabrication, every coincidence, every number that was talked into significance. Take away the stories that did not survive checking. One thing is left standing, and it is not theological. In 1960, the physicist Eugene Wigner gave it a name that stuck: the unreasonable effectiveness of mathematics in the natural sciences. Here is what he meant. 3 cases. In the 1820s, mathematicians started asking, what happens if you drop Euclid's parallel postulate? The answer was a consistent geometry in which parallel lines behave in ways that seemed to describe nothing at all. It was pure abstraction, and some of the people doing it apologized for its uselessness. 90 years later, Einstein needed exactly that geometry. It is the shape of space-time. Second case. Group theory. It was invented to answer a question about polynomial equations. Which ones can be solved by a formula and which cannot? That is the whole reason it exists. It is about the symmetries of the roots of an equation. It turned out to be the language the fundamental particles are written in. The classification of particles is a statement about groups. Nobody was thinking about physics when they built it. Third case, and the strangest of them. Complex numbers began as a bookkeeping trick. 16th century algebraists needed the square root of a negative number as an intermediate step in solving cubics, even though the answer came out real at the end. They did not believe in them. The name imaginary was an insult. They are now the language quantum mechanics is written in. Not a convenience, not a shortcut. The wave function is complex, and the theory does not work without it. In every one of these cases, the mathematics arrived first, for reasons that had nothing to do with physics. Nobody has an accepted explanation for that. Not the theologians, and not the atheists. There are proposals, and none of them commands agreement. Wigner's own conclusion was that it is a wonderful gift, which we neither understand nor deserve. He did not claim to know where the gift came from. That is the honest position, and it is held by people on both sides of the question. Which brings us to Paul Erdos, who did not believe in God at all, and who talked about God constantly. Erdos imagined a book. In it, God keeps the most elegant possible proof of every theorem. When a proof was beautiful, Erdos would say it was straight from the book. You do not have to believe in God, he said, but you have to believe in the book. That is the whole tension of this video inside one person. He is not making a claim about the universe. He is reaching for the only vocabulary anyone has for a certain kind of rightness. There are 2 readings here, and both are held by serious people. The first, mathematics is discovered. It was already true before anyone wrote it down. It would be true if we had never existed. And the fact that it fits the universe so exactly is pointing at something underneath. The second, Mathematics is invented. We built an enormous amount of it. Most of it fits nothing at all, and we only ever notice the pieces that happen to land. The effectiveness looks unreasonable because we are not counting the misses. Neither of those has won. So back to Gödel and what the machine found. His own version, the one from around 1970, is inconsistent. Not wrong in its conclusion. Inconsistent, which is worse. The axioms he chose contradict each other, and from a contradiction you can prove anything at all, including the opposite of what he wanted. Nobody noticed for 43 years. The theorem prover found it automatically. A slightly modified version, written by the logician Dana Scott, is consistent. And in Scott's version the argument is valid. The logic really does hold. But both versions carry something with them, and this is the part almost nobody mentions. They imply what logicians call modal collapse. Everything that is true becomes necessarily true. There is no difference anymore between what is the case and what had to be the case. Think about what that removes. Nothing could have gone differently. No choice was ever open. Every event in your life, and every event before it, was not merely determined, but logically necessary. Believers tend to find that unacceptable because it erases free will. Skeptics find it unacceptable too, because it is an enormous claim about the universe falling out of 5 axioms about the word God. Both camps are uncomfortable, which is exactly why it is worth knowing. The proof is valid. That is not the same as true. Whether it is sound depends on whether you accept the axioms, and the axioms are the whole argument. You have to grant that positive properties behave in a particular way before a single line follows, which is precisely where this argument stood before Gödel wrote anything. The mathematics does not settle the question. What it does, and what it has done for 2,500 years, is show you why the question refuses to go away. Everything in this video was checked. The claims that did not survive checking were labeled on screen rather than quietly left out, because which is the whole point. If that is the kind of thing you want more of, subscribe. I will see you in the next one.